Did advanced civilizations exist on Earth before humanity? Earth is about 4.6 billion years old. That time span allows for enormous imagination. The conclusion of 4.6 billion years comes from multiple independent lines of evidence. For example, the oldest zircon crystals on Earth are about 4.4 billion years old. Moon rocks are about 4.5 billion years old. The oldest meteorites date to 4.567 billion years. And models of the Sun's standard stellar evolution also indicate about 4.6 billion years. Based on these independent pieces of evidence, Earth's age is estimated to be roughly 4.6 billion years. Within these 4.6 billion years, it is theoretically possible that other advanced civilizations evolved on Earth. There may even have been more than one wave of such civilizations. Some could have been more advanced than us, others perhaps comparable to our current level. Later, due to unknown cosmic or planetary catastrophic events, these civilizations may have gone completely extinct. This is a hypothesis proposed by astrophysicists Adam Frank and Gavin Schmidt in a 2018 scientific paper. If that were true, then an obvious question arises. Why have we not found any traces at all left behind by those advanced civilizations? For example, they would certainly have built various high-tech devices, daily use tools, reinforced concrete buildings, or even more advanced structures. In short, they would have produced countless artificial objects. Yet today, on Earth, aside from soil and fossils of various animals, there appears to be no trace whatsoever of an advanced civilization. Does that mean ancient advanced civilizations never existed? In fact, there is another possibility. That is, all artificial objects that could prove the existence of such civilizations were completely destroyed by natural weathering, erosion, and biological degradation. According to current estimates, Earth is 4.6 billion years old. The earliest known ancestors of the genus Homo date back about 2.8 million years. Compared with 4.6 billion years, this is barely even a fraction. We currently believe that life on Earth took more than 4 billion years to evolve. But this conclusion may be overly simplistic. Is it possible that, within these 4.6 billion years, advanced civilizations other than ours once evolved? They may also have built reinforced concrete cities, aluminum alloy airplanes, steel automobiles, electronic devices, and even deep-sea ships. After suffering an unknown catastrophic extinction, could these artificial objects survive the passage of immense time and still be discovered by us today? Next, let us examine what kinds of traces a prehistoric civilization would actually leave behind, and whether we could detect them. First, the fastest things to disappear are organic materials. As far as we know, all known life forms are made of organic matter. Organic matter refers to carbon-based compounds, mainly molecules composed of carbon, hydrogen, oxygen, and nitrogen. That is why we call ourselves carbon-based life. If an ancient carbon-based civilization were suddenly wiped out, then the food they produced, such as fruits, vegetables, bread, and meat, would begin to decompose after only a few hours of exposure to air. Microorganisms would first consume sugars, then break down proteins and fats. As a result, food would spoil, bread would grow mold, milk would turn sour, and meat would rot. Within just weeks to months, bacteria, fungi, and insects would decompose these foods into carbon dioxide, water, and organic residues. And even these organic residues cannot escape the erosion of time. Soil microorganisms would eventually break them down completely, causing them to disappear entirely. In other words, before long, there would be no trace of these foods left on Earth at all. However, within that time frame, the breakdown products of organic matter would still leave chemical signatures, such as anomalies in carbon isotopes. If that civilization had invented paper as a medium for storing information, paper, typically made from plant fibers, such as wood, bamboo, or cotton, would also be subject to degradation. Without any protective measures, paper exposed to moisture, oxygen, and light would gradually be decomposed by microorganisms. In as little as 3 years, it would break down into carbon dioxide and water. However, in dry, low oxygen, and dark environments, paper decays much more slowly and may survive for hundreds or even thousands of years. So what is the oldest complete paper book still in existence? The answer is a Chinese Buddhist scripture. It was printed in the year 868 CE, and today it is 1,157 years old. It is the oldest dated printed book in the world, and is currently preserved in the British Museum. Next comes fabric. Natural textiles such as cotton, linen, wool, and silk, if buried in soil, will be completely decomposed by microorganisms within 1 to 3 years, turning into carbon dioxide, water, and organic nutrients. At this point, one might object, my clothes have lasted for 10 years, aren't they still fine? This is because the degradation rate of fabric depends heavily on the environment. In dry, clean, and well-ventilated conditions, microbial activity is limited, so decomposition occurs much more slowly. Another important reason is that most modern clothing is made from synthetic fibers, such as polyester and nylon. These materials are essentially plastics. Yes, we are, in fact, wearing plastic every day. If a previous civilization had invented similar materials, they could persist in nature for hundreds of years. They degrade slowly because they are petrochemical products, which most microorganisms cannot break down. Instead, over 200 to 500 years, they gradually fragment under ultraviolet radiation and thermal oxidation, turning into microplastic particles. Over time, these microplastics become smaller and smaller, eventually reaching the nanoscale, remaining in soil and water systems, and becoming extremely difficult to fully degrade. Today, microplastics have been found in Arctic ice, the Mariana Trench, and even in human blood. Scientists are currently studying ways to break down microplastics, such as bacteria that can consume plastic, capable of degrading PET plastics. Although the process is extremely slow, there is also a species of fungus, a type of mushroom, capable of degrading plastic. It was first discovered in the tropical rainforest of Ecuador, and can break down polyurethane plastics. One might wonder, how long can media such as photographic film and magnetic tapes, used to store images and sound, last? Typically, their lifespan is around 100 years. If that civilization also invented electronic devices, such as phones and computers, their components, mainly organic materials, metals, and plastics, would generally degrade and lose functionality within about 100 to 500 years in natural environments. However, metals and plastics would continue to persist in subtle forms. Some metals might decompose into toxic substances that enter soil and water systems. That is why electronic waste recycling and disposal are critically important. At this point, it becomes clear that, after about 500 years, all visual and audio records of a civilization would completely disappear. Ironically, much more primitive stone inscriptions can preserve information far longer. Next, let us consider larger time scales. From 500 to 10,000 years, most glass objects would weather into small fragments within about 500 years. After 10,000 years, nearly all glass products would disappear entirely, with only tiny shards possibly remaining underground. Asphalt roads would begin to crack after around 1,000 years. Rainwater and plant growth would gradually break them down, until after about 5,000 years, they would completely turn into soil, leaving no obvious traces. What about reinforced concrete buildings and metal objects, such as bridges, skyscrapers, airplanes, and cars? If exposed to air, steel structures would begin to rust and collapse after about 1,000 years. After roughly 10,000 years, all steel constructions would either be fully oxidized or buried in sedimentary layers. Oxidation would destroy their original structures, reacting with the surrounding environment and transforming them into other minerals. If buried underground, oxidation would slow, but over long periods, water and minerals would still erode them, ultimately erasing their original forms and turning them into barely noticeable mineral deposits. Aircraft fuselages, often made of aluminum alloys, would gradually oxidize and dissolve over about 5,000 years. After 10,000 years, most aluminum objects would become unrecognizable, leaving only trace deposits of aluminum oxides. Reinforced concrete buildings and bridges would begin to loosen and fracture after around 5,000 years, due to weathering and acid rain. After 20,000 years, nearly all structures would turn into rubble, with recognizable traces surviving only under special conditions, such as deep burial underground. Let us expand the time frame further, from 10,000 to 1 million years. By this point, paper money stored in bank vaults would have long since decomposed. The metal safes themselves, however, would take up to 1 million years to lose their original structure and shape, eventually becoming unrecognizable piles of rust. Then there are ceramic objects, such as bowls, plates, and toilets used in daily life. After about 100,000 years, fragments might still exist, but would likely be buried by geological processes. At around 1 million years, a very small number of ceramic fragments might still survive, embedded within strata. Next are metal statues, typically made of copper or stainless steel. After about 100,000 years, they would be severely weathered, forming greenish corrosion layers on the surface. By around 1 million years, these metals would be fully oxidized, becoming unrecognizable masses of oxides. The research by Adam Frank and Gavin Schmidt suggests that, if civilizations existed before the history of the genus Homo, their remains may be buried extremely deep, or may have already been completely eroded, leaving no trace at all.